Hi everyone, this is Babaiah, Assistant Professor of ECE Department, MLR IT, Hyderabad. Now I am going to derive the or solve the some problems based on the RH criterion method for the special case 2. In previous session we learned the how to solve the special case 1 of RH criterion method, which means if any first element of a row is 0, at least one another elements are non-zero elements. In that case we are going to consider the special case 1 and we are going to use some two methods to solve that problem, right? All this we learned from the previous session, but today now I am going to solve the some problem based on the special case by using case 2 by using the RH criterion method. Next, move on to the question here or overview of that case here. If a row of all zeros, any row of all zeros means if we arrange the array matrix in that any row elements all are going to be 0, then we consider that case comes under the here row of all zeros case or case 2 here. So here now from that we are going to solve the one problem based on that special case 2. Just read this question: construct the Routh array and determine the stability of the system whose characteristic equation is s power of 6 plus 2 s power of 5 plus 8 s power of 4 plus 12s cube plus 12t s square plus 16s plus 16 equals to 0, and also determine the roots of the roots lying on the right half of the S plane or left half of the S plane or imaginary axis. Right side, left side and imaginary axis, all roots location. We are going to find or locate the roots of the given characteristic equation in row of all zeros. In row of all zeros, just remember the one thing, if any row, complete row is going to be 0, in that case we are going to say simply some of the roots lying on the definitely imaginary axis in this case. So that's why we say that the system is mostly marginally stable or else limitedly conditionally stable. We say that marginally stable because of imaginary axis we have at least some roots are lying on the, because of a row of all zeros are occur in a array matrix. So that's why we just remember or remember that word. If row all row 0 elements are available in array matrix, then you get the marginally stable system. Maybe marginally is differently. Marginally means what here marginally is here in imaginary axis we are going to get the any rows here imaginary imaginary and here real. So in imaginary any roots are available, this is the marginally we say that. Okay, marginally. So that's why this you can remember this word. And also always a row of all zeros must be in s power of 3 or s power of, that is nothing but the s power of odd coefficient or odd number of s terms. Maximum power is odd number only. In that case, in odd number of row going to be 0 always, because of we are going to consider the auxiliary polynomial equation. In this condition, always auxiliary polynomial equation is the zeroth row above row is the auxiliary polynomial equation, which means always the auxiliary polynomial equation is the even powers of polynomial equation only, simple. So that's why the odd powers of roots or odd number of powers of the row elements are must be 0 elements are occur. Okay, see next, see the problem here. Now consider here s power of 6 plus 2 s power of 5 plus 8 s power of 4 plus 12 s cube plus 20 s square plus 16 s plus 16 equals to 0. Now we are going to solve this problem by using the special case 2. So I am going to arrange the array matrix s power of 6. Here maximum power is what? S power of 6. So order equals to what? 6. So order equals to 6 means how many roots are available? Roots also 6 only. Roots are 6. We have a 6 roots. So out of 6 roots, how many roots on left side, right side or imaginary axis? Now we are going to see that. Right. S power of 6 and s power of 5, sorry 5, s power of 4, s cube and s square, s power of 1, s power of 0. Or otherwise first you should arrange the at least two rows here. S power of 6, so 6 is nothing but even, so even powers, even power of coefficient, s power of 6 1, s power of 4 8, s power of 2 20 and s power of 0 16. Okay, s power of 5 coefficient odd number 2 and s power of 3 12 and s power of 1 16. Any more elements? No, so consider as 0. So here see, next row elements for easy calculation, for simple calculation. Now I am going to do s power of 5 row elements are divide with the 2, divide with the 2. So now divide with 2 and divide with 2, divide with 2 for simple calculation. What is the value I am going to get here? 2 by 2, that is equals to 1. Here 12 by 2 6 and 16 by 2 8 and here this value is 0. So this is the s power of 5 row elements. S power of 5 row elements. Next s power of 4. Now we are going to calculate. So 1 multiply with 8 minus 1 multiply with 6 divided by 1 is our base. So 1 multiply with 8. So 8 minus 6 divided by 1, that is equals to 2. So value is 2. Next here 1 multiply with the 20 and 1 multiply with 8. So 20 minus 8 divided by 1. So 20 minus 8 what? 12. 12 by 1 is 12. Next here, for this row element, we just remove this row elements and just multiply with the next row elements. Okay. Next for this element, remove this one, just multiply with the next row. 1 multiply with 16 minus 1 into 0. So 0 divided by 1, that is equals to 16. So here 16. Next row elements. Next any more elements are there here? No element. So directly consider as 0. Now see, is here also see, observe 2 12 16, 2 12 16. For simple calculation, you can divide with 2 of all elements of the s power of 4, or otherwise you can continue by using all these values also, no problem. Okay, your ratio you can take the for simple calculation purpose you are going to divide with the 2, or otherwise you can solve the problem by using the same values also, no problem, you will get the answer. Okay, so here divide by 2, again divided by 2, divided by 2. So in this row by 2. So what is the value here? 1, 12 by 2 6 and 16 by 2 8 and 0. See, observe, s power of 4 row elements and s power of 5 row elements are same. If two rows are same, then next row automatically it is going to be 0 row only. See, observe how s cube row. See, observe, 1 multiply with the 6 and 1 multiply with the 6. 6 minus 6, 6 minus 6 divided by base is 1. So 1 equals to what? 0. So value is 0. Next here this term, 1 multiply with 6, 1 multiply with 8, 1 multiply with 8. So this value also 0. Here also 0, 0. So here observe, s cube row is 0 row, 0 row element. Zeros row elements, that is the s cube row is the S cube row is the zeroth row or zeroth row element. Okay, so for that, see, observe, odd number of S term, it will get the, or odd number of S terms are going to be get the zeros row. So see here, S cube is what? Odd number. So you will, we are going to get, what is the value? 0 only, 0, 0 only. We got this 0, 0, 0. So all are zeros for the S cube row. For that, now we are going to solve the next values S square elements. See, for example, S square elements directly we are going to solve from here. What will happen? See, 0 multiply with the 6, what? 0. 1 multiply with 0, 0. By 0 is 0 only. Here 0 and 8, 0 and 1 and 0, 0 by something 0, 0, 0, 0. All are 0. Next row also become to 0. Next row again 0, 0. All rows zeros. Right. So that's why we are going to overcome this problem. We are going to assume the, or else consider the auxiliary polynomial equation for solve the problem. Auxiliary polynomial equation means what? The zeroth row above row is nothing but the auxiliary polynomial equation. Always auxiliary polynomial equation is a even powers only. You can remember these two points, very important. Zeroth row above row is the auxiliary polynomial equation. Always auxiliary polynomial equation is the just even powers row. Okay, just you can remember the two words. So S square, for that I am going to consider auxiliary polynomial equation. So auxiliary polynomial equation is what here? S power of 4 is the auxiliary polynomial equation. Because of S cube row is the zeroth row. Zeroth row above row is nothing but the auxiliary polynomial equation. So auxiliary polynomial equation means here even power. So 168. So S power of 4, 1 coefficient. S square, 6 coefficient. S power of 0, 8. Just you simply write. So see, auxiliary polynomial equation, consider auxiliary auxiliary polynomial equation. Consider auxiliary polynomial equation here. Observe what S power of 4 row, 168 coefficients. So 1 S power of 4, 1 S square, S power of 0, 168, that is equals to 0. This is the 168. So this is the auxiliary polynomial equation. Okay, so that is equals to A of S, that is equals to S power of 4 plus 6S square plus 8 equals to 0. And next we are going to just write here, consider this term, and I am going to derivative of auxiliary polynomial equation, and then you will get some value, right? So after that, after the derivation of the auxiliary or differentiate of the auxiliary polynomial with respect to S, we are getting some values. That values are coefficients are the S square or S cube coefficient values. Simply we write that. So I am going to do here derivative or differentiating auxiliary polynomial equation with respect to S, with respect to S. So that is here directly differentiate the A of S, auxiliary polynomial equation, with respect to S. So differentiating here d A of S divided by d S, that is equals to differentiating 4 S cube plus 6 to 12 S power of 1 0. S cube plus 12s plus 0. Right. So S cube coefficient is 4, S power of 1, 12. These are the elements of the S cube row. Now I am going to write all these elements in S cube row, 0th row. So first S power of 6 coefficients what? 1, 8, 20, 16. S power of 6. Again I am going to arrange the array matrix. Array matrix 1, 8, 20, 16. 1, 8, 20, 16. Again here 1, 6, 8, 0. 1, 6, 8, 0. And here S power of 4, 1, 6, 8, 0. Sorry, S power of 4, S cube, S square, S power of 1, S power of 0. S cube row coefficients, S cube, first element 4, next coefficient 12, next is 0. Okay, 4, 12. Next solve, 4, 12 is there. So again S cube row divide with the 4, for example, divide with 4. So 4 divided by 4, what is the value? 1. 12 divided by 4, 3. So I am going to write these values here, 1, 3 and 0. So this is the S power of 3 elements, coefficients or row elements. Now S square calculation, 1 multiply with the 6 minus 1 multiply with the 3. So 6 minus 3 divided by 1. So 3. So here 3. 1 multiply with the 8 minus 1 minus 0. 8 minus 0 by 1. 1, 8, 0. So value is 0. Next elements are 0. So 0. So that's why directly write the 0. 1, 8 and 1, 0. 8 minus 1, 0 by 1. Next element 1, 0, 0. 1, 0, 0, 1 divided by 1. 0 by something is 0. So that's why 0 directly. So S power of 1. S power of 0. S power of 1. Observe. 3 multiply with the 3 minus 1 multiply with the 8. 3 multiply with the 3. 9 minus 8 by 3. 9 minus 8. 1 by 3. 1 by 3 here, 1 by 3, 3, 0, 1, 0. So 0 by something, 0, 0, 0. So 1 by 3. So S power of 0, 1 by 3 multiply with 8. 1 by 3 multiply with 8 minus 0 divided by 1 by 3. So 1 by 3, 1 by 3 both cancel. So value is 8. So value is 8. So here 16. We are already divided with 2. So that's why we get 8 here. 16 by 2, 8. So this is the arrangement. So 8 here. Now we are going to observe the first column elements. This is the first column elements. The first column elements are nothing but all positive. There is no sign change. First column elements there is no sign changes. So all the roots are lying on the left half of the S plane. It is going to be stable condition or a stable system. But we have a auxiliary polynomial equation is there. So auxiliary polynomial equation also including in the main original characteristic equation. Okay, so it is inbuilt of the characteristic equation. So auxiliary polynomial equation is what? S power of 4 plus 6s square plus 8 equals to 0. From that we are going to calculate the roots. The auxiliary polynomial equation roots also roots of the characteristic equation, original characteristic equation. So our auxiliary polynomial equation characteristics are going to be on imaginary or real or right half of the S plane or left half of the S plane or real or imaginary axis. Now we are going to see. Always auxiliary polynomial equation coefficient or roots. Roots of the auxiliary polynomial equation must be on the imaginary axis only. Now we see or calculate the coefficients, roots of the auxiliary polynomial equation. See, auxiliary polynomial equation, what? S power of 4, order 4. So 4 roots we need to find. So now s power of 4 auxiliary polynomial equation, a power of s, that is s power of 4 plus 6s square plus 8, that is equals to 0. Now I am going to substitute s equals to s square equals to x. For the simple calculation purpose, s square equals to x, just I am going to assume or substitute. So x square plus 6x plus 8, that is equals to 0. See, observe, x square plus 6x plus 8 equals to 0. This is what? Second order quadratic equation. So quadratic equation, how to calculate the roots? We are going to use the formula, or else multiply with 8x square, multiplying to 8x square multiply, or otherwise adding 6x. So here 8x square. So directly here ax square plus bx plus c. This is the quadratic equation formula. So here from this, a equals to what? 1. B equals to what is the value? 6. C equals to what? 8. So here value substitute x equals to, or x1 comma x2. So 2, right? Quadratic. So that's why x1 comma x2 minus b plus or minus b square minus 4ac divided by 2a. So here minus b means minus 6 plus or minus b square 6 square minus 4 a 1 c 8 divided by, what is the value? 2a. 2, value a is 1. So what is the value finally? Minus 6 plus or minus, see, 6 square 36 minus 32. So what is the value? 4. Root 4. Root 4 divided by 2. What is the value? Root 4 is nothing but what? 2 minus 6 plus or minus 2 divided by 2. Common the 2 value. So you are going to get 2 minus 3 plus or minus 1 divided by 2. Sorry, 2 get cancelled. Minus 3 plus or minus 1. So finally x1 comma x2 equals to what? Minus 3 plus 1, 1 value, minus 3 minus 1, 1 value. So that is equals to minus 4, 1 value, minus 2, 1 value. Right. Minus 2, minus 2 and minus 4. x1, x2, minus 2, minus 4. Now substitute in place of s, x equals to minus 2, x equals to minus 4, s square. So substitute s square. So in s square, just I am going to substitute s square equals to x, right? So for example, x equals to minus 2. So s square equals to minus 2. S equals to plus or minus under root minus 2. That is equals to what? Plus or minus minus 2 means j square equals to what? Minus 1. So j square equals to minus 1. Minus 1 multiply with the 2. So minus 2. J square square root, both are get cancelled. So j here plus or minus j root 2. That is the 2 roots. Plus j root 2 minus j root 2. 2 roots. For x equals to minus 4. S square equals to minus 4. And s equals to plus or minus minus 4 under root. So plus or minus, again j square equals to minus 1. Minus 1 multiply with the 4, minus 4. So j square. So j root square get cancelled. 2 or 2j. 2 roots. So how many roots? S roots. S1, S2, S3, S4. So minus root 2j r minus j root 2 plus j root 2 minus 2j plus 2j. Now 4 roots. The 4 roots are lying on the imaginary axis. Because of j terms imaginary, all 4 roots on imaginary axis. Total how many roots? Total 6 roots. Maximum power is what? Maximum power 6. So 6 roots we have. From that 4 roots on imaginary axis. 4 roots are imaginary axis. 6 total 6 roots. Remaining two roots on left of the S plane. Because of there is a no sign change in first column, so remaining roots on left half of the S plane. Then the system is marginally stable. Marginally stable system. So observe here what? First total 4 roots on imaginary, 2 roots on left half of the S plane. So then the system is marginally stable system. Marginally stable system. I hope you understand. This is the very important case. Just what we observe, how to follow this in special case 2. Just arrange the array matrix, and for easy purpose we are going to divide or multiply. Anything you can do for simple calculation. When we are going to get the zeroth row, then we are going to consider the auxiliary polynomial equation. Auxiliary polynomial equation is nothing but what? The zeroth row above row is the auxiliary polynomial equation, and auxiliary polynomial equation going to be derivative or differentiating with respect to the s. Then you are going to get the coefficients of the zeroth row. Just write that coefficients, again solve the or follow the same procedure to solve the remaining row elements, and observe the first column elements. If any roots sign changes are there, just observe. If any sign changes are there, that sign changes are nothing but the roots. That roots are right half of the S plane. If any sign changes are not there, all the roots are on the left half of the S plane. But we have a polynomial equation. Auxiliary polynomial equation is there. So auxiliary polynomial equation also part of the characteristic equation. So that's why we are going to consider the roots of that auxiliary polynomial equation. So from that auxiliary polynomial equation, roots always on the imaginary axis. So then the system is marginally stable system. So out of 6 roots, 4 roots on the imaginary axis, remaining 2 roots on the left half of the S plane, then the system is marginally stable system. I hope you understand. Next we are going to see the next classes also. So these are the very important RH criterion special cases up to till. I hope you understand. These are the very important topics. Thank you all.